Hi, happy people. This is Mr. Wilcox coming to you again from my kitchen table. We're going to finish off our very short look at sequences and series. We're just looking at what sigma notation looks like for arithmetic series and geometric series. Um, so that is what we are going to look at today. And then the rest of the year, we're going to be talking about trigonometry. So for sigma notation, uh, if we have an arithmetic series, here's what it looks like. I'm going to pause here so you can write this in your notebook. And when you're ready, just hit play on your video game. So remember, an arithmetic sequence or an arithmetic series, remember a sequence is just the list of numbers, in a series we add them up. So for an arithmetic series, we're adding the same number over and over again. So we have that common difference, and that's D. And so it looks like our summation notation has a D times some number plus a C. So if you notice, that looks an awful lot like mx plus b. That's because arithmetic series where we add the same number every time makes a linear function. So an example would be if we're taking the sum of, I need that to go away, the sum of the series that has the first four terms for 3k minus 1. That would be an arithmetic series because we have a common difference times our k, and we're adding or subtracting a number afterwards. A geometric series, on the other hand, remember though, we are multiplying the same number. So again, I'm going to pause so you can write this in your notebook, and when you are done, go ahead and hit play again. So our geometric series, remember, have a common ratio r. And so what those are going to look like is taking a constant times that common ratio r to the k power or the k minus 1 power. So our example here is the first 0 to 10 terms of 4 times 3 to the k power. So these look more like the exponential functions that we're using when we're talking about logs, because they are going to grow exponentially quick. All right, so that's the difference between an arithmetic and a geometric series. So for all our examples, we're going to tell whether the series is arithmetic or geometric, and then we're going to find the sum. So this is the first example, so I'm going to pause so you can write that down, and when you're ready, hit play again. All right, so first of all, is this series arithmetic or geometric? So are we looking at a common difference or a common ratio? Well, it looks like we are going to take a number times our k and then add something on. So that means we're going to have the common difference, and our common difference there is going to be 4. So this series is arithmetic. And then we have to find the sum. And how we're going to find the sum is just like we were doing when we were introduced to series. So we're just going to plug in our 1 through 4. So if I take 4 times 1 and I add 8, I will have 12. If I take 4 times 2 and I add 8, I have 16. If I take 4 times 3 and I add 8, I will have 20. If I take 4 times 4 and I add 8, I have 24. And if I take 4 times 5 and I add 8, I have 28. So if I add 12 plus 16 plus 20 plus 24 plus 28, and I add them all up, I get 100. So our series is arithmetic, and it sums to 100. All right, I have one more example for you. And we are again going to tell whether the series is arithmetic or geometric and find the sum. So this time we are finding the sum of the series from 1 to 4 of 2 times 3 to the k minus 1. And since we're taking 3 to our k power, that means 3 is our common ratio. So 3 would be the number we're multiplying in between. And so that makes this series geometric. So we're multiplying by 3 every time. So again, we're going to find our sum of our series by plugging in the numbers 1 through 4 into our equation and then adding up what we get. So if we take 2 times 3 to the 1 minus 1, that gets us 2 times 3 to the 0 power. So 3 to the 0 power is 1. 1 times 2 is 2. If we take 2 times 3 to the 2 minus 1 power, that gets us 2 times 3 to the first. 3 to the first is 3 times 2 is 6. If I take 2 times 3 times 3 to the minus 1 power, that's going to give me 2 to the 3 squared. 3 squared is 9. 9 times 2 is 18. And then if I take 2 times 3 to the 4 minus 1, I get 2 times 3 cubed. 3 cubed is 27, and 27 cubed is 54. So if I take 2 plus 6 plus 18 plus 54, I get 80. So this series is geometric and sums to 80. So that's looking at series in sigma form and telling if they're arithmetic or geometric and finding the sum. So I hope you have a great day. I hope you're happy and you're healthy. And again, I hope you all have a great day.